Hello my dear friends, welcome back to your channel of learning. Now in the previous session I have finished the 3-mark questions. So now we'll move to the next session that's about solving for 5-mark questions. Okay, 5-mark questions given by the NBSE 5-mark questions question bank. Alright, so now there are about 15 questions. So I'll not be starting from question number 1. Okay, this will be the second session. So second part. Now I will be starting from question number 8. That's from the trigonometry part. Question number 8 onwards. So I've written down the question for you. That is, from the top of a 7-meter high building, the angle of elevation of the top of a cable tower. Building, tower. Always tower is always lower, isn't it? I guess I don't think our house is taller than the tower, no? So here actually we do require some, just some common sense also. Okay. From the top of a 7-meter high building, let's just start with the figure. From the top of a 7-meter high building, let's say the building is here. The angle of elevation of the top of a tower, let's say AB be our tower, CD be our building. Let AB be the tower and CD be the building. The angle of elevation of the top of a cable tower is 60 degrees. The angle of elevation of the top of a cable tower is 60 degrees. So from the top of a 7-meter high building, this is 7 meter. From the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees, and the angle of depression of its foot. And the angle of depression of its foot is 45 degrees. So these two will be parallel because the ground is always a straight line. So we are going to be drawing the line of sight to be parallel only. So if these two are parallel lines and if this is angle of depression is 45 degrees, so this angle will also be definitely 45 degrees. You must already know that. Why? Reason, of course, alternate interior angles, concept of parallel lines only. Once again, from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees. And the angle of depression of its foot is 45 degrees. Find the height of the tower. So we are supposed to find out the height of the tower. So now since these two are parallel lines going, if this is 7, if CD is 7, exactly BE also definitely will be 7 meter. If you wish, you can write. Since DE is parallel to CB, CD will be equal to BE, that will also be 7 meter. We are supposed to find AB, that is the height of the tower. So AB actually will be BE plus AE. We are going to use this to find out the height of the tower. Okay? I will, now all the questions are written, I'll rub off the questions. So if you have a 45-degree angle, it's better to start with that 45-degree angle if you're dealing with perpendicular height and base. So in right triangle BCD, tan 45 degree, no need to mention this because in the figure we have already mentioned properly, so that should be enough. Tan 45 degree is equal to perpendicular height by base, as we know it, opposite side by adjacent side. So it's CD by BC. Now tan 45 we know it's 1, CD is 7, BC we don't know. So cross multiply, BC becomes 7 meter. So that means BC is also 7 meters. So again, these two are also parallel again, isn't it? Towers, buildings generally will, not the leaning tower of Pisa, no? So towers definitely were buildings always straight. So they are automatically parallel also. Okay, so this one finished. I'll wrap this off. So in that case, I'll just continue here. Since CD is also parallel to AB, what will happen is BC of course will be equal to DE, that is also equal to 7 meter. Alright, now in triangle AED, in right triangle AED, now in right triangle AED, again tan 60 is equal to perpendicular height AE by adjacent side EB. Tan 60 we know it's root 3. AE we don't know, we will find out, no problem. ED just now only we have mentioned. ED or DE, it's all the same. Okay, let me just write so that you don't confuse. DE doesn't matter, but it's okay, no problem. So that will also be 7. So in that case, AE will be by cross multiplying 7 root over of 3 meter. So what will be the height of the building then? Tower, sorry. Height of tower AB. AE plus BE. What is AE? 7 root 3 plus meter plus BE 7 meter. So that will be by taking 7 root 3 plus 1 meter. So this is the height of the tower. Okay, so you can pause and write down. Okay. Next question, let's move to the next question. It's a long question, but anyway I'll write down because it seems like some of you don't have the question with you. A statue 1.6 meter tall stands on the top of a pedestal. Pedestal means stand. So if this is a level ground, if this is a pedestal stand, then the statue stands on this 1.6. From a point on the ground, let's say from this point, from a point on the ground, the angle of elevation of the top of the statue is 60 degree. Angle of the elevation of the top of the statue, this is the statue CD. So angle of elevation of the top of the statue is 60 degree. And from the same point, the angle of elevation, the angle of elevation of the top of the pedestal is 45 degree. Top of the pedestal, this is 45 degree. Find the height of the pedestal. Solution: let BC be the pedestal, CD, which is 1.6 meter, be the height of the statue. I'm just writing in short, statue. And that should be enough, no need to explain too many things. Now straight, as I said, if you have a 45 degree, let's go for 45 degree first. In right triangle ABC. In right triangle ABC, tan 45 degree is equal to BC by AB. What are we trying to find out? BC. Height of the pedestal. We are trying to find out BC. Directly we might not get, that's why they have given us the figure. Shall I rub now the question? Okay. So tan 45 is 1, BC we don't know, AB also we don't know, cross multiply, AB is equal to BC. We might need this equation, we'll keep it. We'll go to the bigger triangle. In right triangle ABD again. Tan of 60 degree will be equal to BD by AB. So tan 60 root 3. I'll just write here so that in one space we can do. BD we don't know, but BD we can write as BC plus CD. No problem. AB I can write as BC, no problem. We're trying to find out BC, so using 1 also, no? Because AB is BC, so instead of AB I can use BC, and BD is full length. BD I can write as BC plus CD, not a big problem there. So that's going to be root 3 BC is equal to BC plus CD is 1.6. So root 3 BC minus BC is equal to 1.6. So taking BC common, I will have root 3 minus 1 is equal to 1.6. So that means BC will be equal to 1.6 divided by root 3 minus 1. So I will just rationalize this. So 1.6 divided by root 3 minus 1 into root 3 plus 1, rationalizing the denominator, root 3 plus 1. So that's going to be 1.6 root 3 plus 1 divided by a plus b into a minus b. That is a square minus b square. A plus b, a minus b is a square minus b square. So that's 1.6 root 3 plus 1. Root 3 square is 3, 1 square is 1. That's right here. 1.6 root 3 plus 1, 2. If we divide by 2, 1, 0.8. So that's like 0.8 root 3 plus 1 meter or centimeter, whatever be that unit. Meter. Okay, so that's the height of the what? Pedestal, no? Yes. Okay, moving on to question number 10. This is from circles. So I've done this completely on this chapter of circles. Complete solution is there. You can check the playlist. It's completely there, and I'll be providing the link below also. Prove that the angle between the two tangents drawn from an external point to a circle is Supplementary. Supplementary means combined angle is 180 degree. Supplementary to the angle subtended or made by the line segment joining the points of contact at the center. So the question is, prove that the angle between two tangents drawn from an external point. So we will have a circle. Doesn't even, it might not look like a circle, but come on. Okay, I tried my best. Circle, center. Let's say O. Prove that the angle between two tangents drawn from an external point. So external point, let's say P. So from the external point, like we draw two tangents, points of contact. Let's say A, B. Prove that the angle between two tangents, this is the angle between two tangents, no? This is supplementary to the angle subtended by the line segment joining the points of contact at the center, point of contact at the center. These two angle is supplementary. Given a circle with, let's say, just say center O. Consider, that will be better. Consider a circle with center O and tangents from P, PA and PB. To prove, you can write in your own words, no problem. This, to prove, we are supposed to prove that the angle between two tangents APB plus angle AOB are supplementary 180 degree. Let's go for the proof part. What we know is, we know that the angle, we know that, let's say, in short, tangent is perpendicular to the, in short only, okay, radius. True, you know that tangent is perpendicular, you know that a tangent is perpendicular to the radius through the point of, in short only I have written the theorem is something like a tangent is always perpendicular to the radius joining the point of contact and the center. So we know that a tangent is perpendicular, that means this is a tangent, point of contact, we join that to the center, through the point of contact to the center, it is 90 degrees. So we know that tangent is perpendicular to the radius of a circle through the point of contact, something like that, or joining the center, okay? Alright, so that's how it will be written. So in that case, this is 90 degree. Similarly, this one also, tangent, point of contact, center joining, this is also 90 degree. Therefore, angle PAO is equal to angle PBO. Both will be 90 degree. Now PAO, PBO. Point of contact, center, tangent, 90, 90, 90. Very simple diagram. I mean, very simple question. Okay, don't miss out this question. Now you see, what is this figure? It has how many sides? 1, 2, 3, 4. So this has 4 sides. 4 sides means a quadrilateral. I'll write in short. Quadrilateral PAOB. Now one thing that we know in quadrilateral is the sum of all the angles, 4 angles of a quadrilateral is how much? 360 degree. So that means angle APB plus angle AOB plus angle PAO plus, I'll just wrap this part, we don't need this anymore, plus, I just want to write in one line, PBO. Sum of all the 4 angles in a quadrilateral, I'll wrap this no more, is how much? 360 degree. So angle APB plus angle AOB plus 90 plus 90, it's already proved above, 90 degree equal to 360 degree. So therefore angle APB plus angle AOB will be equal to 360 minus 90 minus 90. So angle APB plus angle AOB is equal to 180 degree, hence the proof. So even those students who don't like geometry and all, yeah, this is a very simple question. Yeah. Okay, so don't miss out this question. Okay, so you can pause the video there. Okay, and write down. Okay, so it's a very simple proof. And detail wise, I've done it in the other videos. Complete solution of the circles we'll have. So you can check the playlist or you can check the link below later on. 11. It's something like this. PAQ is a tangent to the circle with center O at the point A, as shown in the joining figure. So this is our, let's say, center, then we have like a tangent P A Q okay, I'll just draw the figure like this. Figure might look slightly different. Okay, chalo. Just draw like this. So this is the center. Even though it doesn't look like a center, please adjust. Circle to difficult enough to draw with using bare hands. Like, of course, with time I can, but I mean, no. It gets worse day by day. Chalo, maybe still doesn't look. Anyway, please. Why? So one thing that we know, just now only we have seen, this is pakka 90 degree. If angle OBA is 35 degree, OBA, where's B? Okay. So then now it's something like this, this. Then we have the figure again, something like this, C. This was my 90 degree, okay. OBA, where's OBA? Okay, OBA, 35 degree. Find angle BAQ and angle ACB. BAQ, this one. Angle BAQ You have to find this angle. And ACB. Okay, simple solution. Given a tangent PAQ to a circle with center O. So OA definitely is perpendicular to PQ. OA is definitely perpendicular to PQ. In short only I'm writing tangent is perpendicular to radius through the point of GH, through the point of contact. So that means angle OAQ is 90 degree. Now this one OAQ, this full angle. We are supposed to find out just a part of this angle. How do we do that? Simple, very simple, always simple, always simple. Now we will require a little bit of the basics of class 9. If you remember, we know that in a triangle, if opposite sides are equal, then opposite angles are also equal. If AB is equal to AC, then angle B is equal to angle C. OA is equal to OB. Why? OA, OB. Why is it? Because both are radii. Radii means a plural form. Radius of circle. So therefore in that case, as I mentioned, angle OAB will also be equal to angle OBA. That means these two sides are equal in this triangle. So in that case, this angle in the triangle, triangle ga under these two angles will be equal. And what is OBA? 35 degree. So then you see this full angle is 90, so it's something like this. This is 90, and this is that A and this is that B part going. So if this full is 90 and this one we've got 35, then how much will be this one, which we're supposed to find out? This full was 90, one part is 35. So the remaining 90 minus 35, because full is 90 out of that 35 already found, so this is 90 minus 35, so simple. So therefore angle BAQ will be simply 90 degree, something like, I'll just write angle OAQ minus angle OAB. So that will be 90 minus 35 degree. So 90 minus 35, 5, 3, 4, 5, 6, 7, 8. So angle BAQ is again OAQ minus OAB. OAQ minus OAB, so that's as mentioned. 90 minus 35, so that is 55 degrees. So one question is already done. BAQ already calculated. Alright. So next our job is to find ACB. Now for that, if you remember one theorem, the angle formed at the center is always like half of the angle on the other segment, if you remember in class 9. So we will need that theorem, but for that let's find out this angle. In triangle OAB, angle OAB plus angle AOB plus angle OBA, how much? 180 degree. OAB 35, now that's what we calculated. AOB we need to find out, this is also 35, 180, so AOB 180, angle AOB plus 70, 180, angle AOB will be equal to 180 minus 70, so that's like 110 degree. So this is 110 degrees. So from that theorem in circles, this will be always half of the circle in the same segment. So 110, half of that. Okay. So let's write down that theorem. So I'll just write down here. We know that angle subtended by an arc. We know that angle subtended by an arc at the center. We know that angle subtended by an arc at the center is double the angle the angle subtended by it, by the arc, by it at any point, on the remaining part of the circle, which implies, or that is, angle ACB. We know that angle subtended by an arc at the center, AOB, is double the angle subtended by it at any point on the remaining part. Angle double of angle ACB. So we just bring this half, angle AOB is equal to angle ACB, or angle ACB is equal to half of angle AOB. So that is half of angle AOB is 110 degrees, so 255, so 55 degree. So angle ACB is also how much? 55 degree. So in the exams, of course, you don't have to write this if you don't remember. I'm just giving it to you so that you know how is it happening. So you can just write like, we know that. Nah? If you forget this part, you can just write down. It's okay, no problem. We know that angle AOB center is equal to double of the angle on the remaining part of the circle, say, formed by the arcs. That will also be fine. This I'm giving it to you so that you know how it comes, because this comes from class 9 concept. Okay, so that's how it is. All right, so definitely the first question of that circles is much easier compared to this, because that is very simple. Okay, so all right then. So you can practice these questions. I will continue with the questions of mensuration and statistics in the next part, in the next session. So in the meantime, you can just get ready to practice these particular questions. Alright, so till then, study well, stay safe. I'll see you very soon.